Hello, this is Mr. Henry, and welcome to Lesson 3.1. We are starting a new chapter. This chapter is devoted to solving equations. This should not be a new concept for you by 8th grade. You should have learned this some point previously. In fact, probably multiple times. So this first lesson is going to be a nice little refresher. It should be very easy, but the problems are going to get more difficult fairly quickly in the next few lessons. So don't slack off too much and just rest and think this is going to be super easy the whole time. So the first lesson here is solving one-step linear equations. The essential question says, how do I solve one-step linear equations? Pretty straightforward. Did you know that a one-step equation happens every time you ask yourself a simple sort of math question like, I have $4. I'm going to move that costs 10. Well, how much money do I need to ask mom for? That could be represented as a one-step equation. I'm going to install a fence. I need to put a post every 8 feet. If I need 96 feet of fencing, how many posts do I need? Most of those you probably wouldn't sit down on a piece of paper and write out an equation and solve it that way. You'd probably just do it in your head or pull out your calculator. But this is going to be the basis for what we're doing later on. It's very easy to do a one-step equation in your head most of the time. What gets much more challenging is when you have a multi-step equation with variables on both sides that it takes 5 or 6 or 7 steps you can't do in your head, and if you don't understand the skills we're going to learn in this lesson, you're not going to be able to do those harder equations either. Okay? So we have two vocab words here. We have equations and reciprocal. So an equation. An equation is a statement where the value of one side of the equal sign is the same as the value on the other. So both sides have the same value. So like 3 equals 3 is technically an equation. This side is the same as this side. Or if I said 2x equals 8, I'm saying that these two sides are equal. And a lot of times our goal is to figure out, well, what is that number that makes this side equal that side? In this case, hopefully you know the answer is 4. Reciprocal. This is going to come into play later on in the lesson when we're talking about solving equations with fractions in front. But the reciprocal is when you take a fraction and you flip it upside down. So if I had the fraction, say, 3/4, the reciprocal of that is 4/3. If I have a number 8, and I said, what's the reciprocal of 8? Because as a fraction, 8 is 8 over 1. You would flip this upside down and you would get the fraction 1/8. Okay? So a reciprocal is when you take a fraction and you flip it upside down. The numerator becomes the denominator and the denominator becomes the numerator. Example 1. So in this first example, all we're really doing is checking to see if a value that we get is an answer for an equation. This is very useful in multiple choice questions because if they give you an equation, they say, hey, which of these 4 choices is your answer? A lot of times, honestly, you don't even have to solve the equation. A lot of times you can just take the possible answers they give you, plug them into the equation, and see which one works out. So for example, here, I'm taking this equation and I would check these 4 numbers to see if there's solutions. Only one of them will be. So if I plug in 2, 4 times 2 equals 20. Well, check the math. Does 4 times 2 equal 20? No. Okay, what about 4 times, the next number is 5. 4 times 5 equals 20. Does 4 times 5 equal 20? Yes. So 5 is the correct answer for this equation. Now you might have known that off the top of your head. Yes, 4 times 5 is 20. But I'm showing you that you can check your answers to any equation. Even later on in the other lessons, when the equations get very long and ugly and complicated and take 10 minutes to solve, in the end, you can check your answer to those problems by just doing a quick little plug in your solution into the variables and see if you got the right answer. See if the math works out. Okay, letter B. I'm going to plug in each. So is 2 plus 3 equal to 13? No. Is 5 plus 3 equal to 13? No. Is 8 plus 3 equal to 13? No. Is 10 plus 3 equal to 13? Yes. So that is the solution. When h equals 10, that is the solution to this equation. Okay? Go ahead and try these two on your own. You're just checking to see if these values are solutions to these equations. So pause the video, try them on your own. When you're ready to continue, hit play, and we will go through them together. All right, so letter C here. I'm just going to start plugging in. So I'm going to check, is 2 divided by 2 equal to 4? I'm plugging in the first value. No, 2 divided by 2 is 1. Is 5 divided by 2 equal to 4? I plugged in the second value for the variable. No. Plug in the third value. Is 8 divided by 2 equal to 4? Yes. 8 divided by 2 is 4. And I don't even have to check the 10. I know it's not going to work. 10 divided by 2 equals 4? No, because we knew that it's 8 that worked out for us. 8 divided by 2 is 4. So that means 10 can't work, 5 can't work, and 2 can't work. There's only one solution. Letter D. Okay, negative 3 plus 2 equals 5. Well, if you're not paying attention to the signs, you might say yes. But here, because this is a negative 3, the answer is no. Negative 3 plus 5 equals 5? No. And if you're not sure, you can double check on your calculator. I'm okay with that. Negative 3 plus 5 is 2. So no, that doesn't work. Negative 3 plus 8 equals 5? Yes. Negative 3 plus 8 does equal 5. So the solution here is when p equals 8, that makes this equation true. That's the only one that would work. If I plug in the 10, it's not going to work. Okay? So this is just checking your answer. So now let's get to actually solving. So when you're solving an equation, your job is to always get the variable by itself. To get rid of all the things that are being added and subtracted and multiplied and divided and squared and square rooted from the variable. You want, in the end, just y equals. You want m equals. You want down here p equals. You want a equals. Okay, that's going to be your goal. So in this problem here, and a lot of people put this line down their equal sign to help keep the two sides of the problem separate. They've got this side and this side, the left and the right. Your job is to get rid of everything else on the same side of the problem as the variable. So my variable's on the left here, so I need to get rid of this plus 8. And the way you get rid of everything when you're solving an equation is you do the opposite of what's happening to the variable. So here, my variable is being added by 8. This is a positive 8. So in order to get rid of this positive 8 or plus 8, I'm going to do the opposite, and I am going to subtract 8 on both sides. You always do everything on both sides of your equal sign. When you do, you get y equals, and 5 minus 8 is negative 3. And that's done. Y is negative 3. Now, I could check this if I wanted to, just to make sure I'm right. Is 8 plus negative 3 equal to 5? I don't know. Actually, I do know, but let's check it. 8 plus negative 3 equals 5. By the way, if you try to using the minus sign for negative, the calculator's not going to like you. If you said 8 plus negative 3 like this, notice how it looks different on the calculator? It's going to give you an error. This is not a negative in terms of what the calculator cares about. This is your little negative sign. Okay? Letter B. So here, my variable is being multiplied by 12. This is a multiplication. This is 12 times m. So the way you get rid of a multiply is by doing the opposite. What is the opposite of multiply? It's divide. So we're going to divide both sides by 12. I'm not dividing by 36. I don't care about him. This 12 is the one I want to get rid of. And so when I take 12 divided by 12, what I get is I would get 1m. 12 divided by 12 is 1. On the other side, 36 divided by 12 is 3. Now, this 1m, this 1 is kind of like a ghost 1. He's one of those ones that I don't really need here, that sometimes we write him, sometimes we don't, so I'll throw him in as a ghost 1. I don't need to actually write that 1 in there. Right here, there is one y right there. 1, because I don't have a 2 or a 3 or a 5. There's one y right here. But I don't need to write the 1. And that's kind of our goal. Our goal is to get the variable by itself, or to make it so there's just one of the variable by itself. So if you have 1m equals 3 and you stopped there, that's fine. But most people would erase that 1 and make it just m equals 3. And it does work out, because if you take 12 times by 3, you do get 36. This math checks out. Okay, so we saw an add, we saw a multiply. Here's a subtract. So my variable is being subtracted by 8, p minus 8. So how do you get rid of a minus 8? How do you get rid of that? The opposite of minusing 8 is adding 8 on both sides. So when you add 8 on both sides, this side, you get just p equals. 8 minus 8 is 0, they're gone. 5 plus 8 is 13. And I'm done. Reminder, this is 1p equals 13. Letter D. Can I separate this a little bit? Yeah, oh well. So here, my variable is being divided by 4. What is the opposite of divide by 4? The opposite of divide is multiply. So we're going to multiply by 4 on both sides. So what happens here is a multiply by 4 and a divide by 4 cancel. Think of this as, this would be, after I multiply by 4, it would be 4a divided by 4. These 4's would simplify, giving me 1a. There's that ghost 1 again that I don't really need to write. So these cancel out. So we can think of them as going away. There is still technically 1a there, but we don't need to write the 1. On the other side, when I take negative 16 times by 4, negative 16 times by 4 is negative 64. And let's play pretend you're a little unsure on whether this is right or wrong. You can always do it. It takes a couple seconds. Is negative 64, the thing we got for a, is negative 64 divided by 4 equal to negative 16? Well, calculator it. Is negative 64 divided by 4 equal to negative 16? Yes. Yes, it is. So we've proven, we've checked our answer, and we saw that our answer is, in fact, a equals negative 64. Example 2. Or it's just more of the same. So I did the first 4. I would like you to do these 4, please. So go ahead, pause the video, try these 4 problems on your own right now. When you are ready to continue, hit play, and we will go through them together. Okay, so let's see here. Hopefully you started by subtracting 3. Because you need to get the variable by itself, and if you get rid of this 3 that was being added, then this goes away, and you have just m equals. On the other side, when you subtract 3, negative 3 minus 3 is negative 6. And when you type that in the calculator, because this is an example, I see a lot of mistakes people typing in the calculator. A lot of people do this. They do negative 3 minus negative 3, and they get 0. If you got 0, you probably did this. This is not right. Look, this first one is negative 3. I think we can all agree with that. Negative 3. Now, to type in this bottom thing, you have to do one of two things. Either you do just minus 3, negative 3 minus 3, negative 6. Or, if you think this is a negative, then you have to do plus negative 3. If you do negative 3 here, plus a negative 3 here, giving you negative 6. It is not negative 3 minus negative 3. There's not another minus sign out here. If there was, then you would do negative 3 minus negative 3. But there's not, okay? Letter F. My variable is being divided by -2. So the opposite of dividing by -2 is to multiply both sides by -2. These -2's cancel, giving me 1r. There's 1r here. 5 times -2 is -10. Done. And I can double check very quickly in my head. -10 divided by -2 equals 5. The answer is yes. Yes, it does. This math checks out. Letter G. -3 plus w equals 9. So my variable here is being added by -3. So this is a confusing problem for some students. They don't know whether they're supposed to add the 3 away or subtract the 3 because they go, oh, that's a plus sign, so I'm supposed to subtract this way, right? Well, no. You want this piece right here to equal 0. You want it to go away. And the only way you're going to get that piece to equal 0 is if you add 3. Check it out. -3 plus 3 is 0. These signs, when you're getting rid of an add and subtract, the signs will be different. So if you think this is a -3, use a +3. And on the other side. So now w equals, these cancel out, give you 0. That's what we wanted. We wanted that to equal 0. 9 plus 3 is 12. Over here, I need to get rid of this -6. So this -6 is going to go away, just kind of like it went away over here. To get rid of a -6, I use a +6. To get rid of a -6, I do +6 on both sides. And we get u equals 0 plus 6 is 6. Okay, 4 more. We're just getting practice. We got to get good. So we get some practice to make sure we understand what's going on. So go ahead, copy these 4 problems down, pause the video, try them on your own. When you are ready to continue, hit play, and we'll go through them together. Okay, so I'm going to solve. My variable is being subtracted by 4. So the way we get rid of a -4 is we do the opposite, which is we are going to add 4 to both sides. So these guys cancel, and we get t equals, let's see, so -3 plus 4 is 1. So t equals 1. And we can always double check it. If I take 1 minus 4, do I get -3 for an answer? Yes. So t does indeed equal 1. Letter J. My variable is on the other side this time. That's okay. And he is being multiplied by 7. So I need to do the opposite. I need to do the opposite of multiply by 7, which is dividing by 7 on both sides. So when I divide by 7, these 7's cancel out. They give me 1h, and I do not need to write the 1. 1h equals 28 divided by 7 is 4. Letter K. I'm going to solve here, so I need to get the variable by itself. He is on the right up top. So I need to, in the end, want this to be g equals. So in order to get this g by itself, I have to get rid of this divide by -7. The opposite of dividing by -7 is to multiply both sides by -7. So this multiply by 7 and this divide by -7 cancel. They're opposites. In fact, it gives me 1g. -7 divided by -7 is 1. So I'd have 1g equals, and on the other side, I don't know, 7 times by, well, I'll do my signs too. -7 times by -14 equals 98. Positive 98. And last of these, I think, is letter L. My variable is being multiplied by negative 2. Q is being multiplied by negative 2. So the opposite of multiply by negative 2 is to divide by negative 2 on both sides. So these negative 2's then would cancel, and I get Q equals negative 6 divided by negative 2 is a positive 3. And check your work. If I had negative 2 times by 3, does that equal negative 6? It should. Negative 2 times by 3 equals negative 6. So those were all one-step equations. Now, make it a little bit more challenging here. Slightly different type of problem. So now what we're looking at here is these are still one-step equations, but now my variable is being multiplied by a fraction. You see how that's negative 2/7 x? So the way we can get rid of this is we're going to use that one vocab word, which was the reciprocal. The reciprocal is when you take a fraction, you flip it upside down, right? So there is a rule in math that you might have learned back in 7th grade that said that when you're dividing fractions, let me group this, move him out of the way. All right. So if you had, play pretend, like 1/5 divided by 2/3. If you were trying to divide this back in 6th grade, 7th grade, whenever you learned to do this, the rule in math says in order to divide fractions, you flip the second one and you multiply. Or you take the reciprocal of the second fraction and then multiply. And you would multiply straight across and get, what, 3/10. Okay? That's the rule for dividing fractions. Now, how that relates to what we're doing here is this is negative 2/7 times by x. I would like to get rid of that negative 2/7. So the way that I'm going to do this is I'm actually going to multiply by the reciprocal. I'm going to divide by negative 2/7, but the rule for dividing fractions is you flip it, that's the reciprocal, and you multiply. So if I multiply both sides by the reciprocal, watch what happens here. So this is the reciprocal of that fraction on both sides. Now, on this side, on the left-hand side, these two fractions actually cancel each other out. I'm dividing by the same thing. So here, if I would multiply my fraction, check this out. Negative 7 times negative 2 is 14. On the bottom, 2 times 7 is 14. What's 14 over 14 equal? 1. This gives me 1x. And I don't, ooh, that's not what I meant to write. I actually meant to write x. Come on. There you go. And I don't need to write that 1. Just like in the previous problems, I didn't need to write the 1. When I divided by negative 2 on both sides here, I didn't have to write down I got 1q. I just put down q. Here, these two fractions are opposites of each other. They're reciprocals of each other. So when I multiply them together, it gives me 1. So this is equal to 1x. Now, on the other side, to multiply this together, I'm going to turn the 4 into a fraction. 4 over 1. Now, when you multiply your fractions, you multiply across the top, you multiply across the bottom, and then simplify your answer. So across the top, I get 4 times negative 7 is negative 28. Across the bottom, 1 times 2 is 2. And if we simplify that, you can throw it into a calculator as a fraction if you'd like. Negative 28 fraction 2 equals, it's negative 14. That is the simplified version of this fraction. It's just the number negative 14. So it seems a little complicated, but everything seems hard at first. The very first time you see it, it's not that bad. The rule is, the trick is, you multiply by the reciprocal. Here, my fraction is 1/5 being multiplied by k. if I multiply both sides by the reciprocal of that fraction, by 5 over 1, what happens is this 1/5 times by this 5 over 1, if I multiply across the top and I multiply across the bottom, gives me 5 over 5. That is equal to 1. These two fractions together, when you multiply them together, give me 1k. And I don't really need that 1 there. On the other side, when you multiply, you have to turn your whole number into a fraction by putting it over 1. You multiply across the top, you multiply across the bottom, and you get 25 over 1, which you don't really need the over 1, so we'll just call it 25. So k equals 25, or possibly 25 over 1. By multiplying by the reciprocal, we are canceling out the fraction. We're making the fractions equal 1. And we do not need the ghost 1 in front of the variable. Okay. Here are 2 for you to try. Go ahead and pause the video. Do the 2 problems right now. When you are ready to continue, hit play, and we will go through them together. Okay, so letter C. In order to get rid of this times by 3/4, I'm going to multiply by the reciprocal. That makes this piece here equal 12 over 12. If I multiply across the top, I get 12. Multiply across the bottom, I get 12. And 12 over 12 is equal to 1m. On the other side, when you multiply by 4 over 3, you got to make this guy a fraction. To multiply fractions, you multiply across the top and across the bottom, so I need a bottom part of this fraction. So now that gives me negative 24 over 3. Simplify your fraction. Negative 24 over 3 is just equal to negative 8. 24 divided by 3. Letter D, same dealio. Here is my variable is being multiplied by 1/3. So if I multiply both sides by the reciprocal here, that makes this equal 1. 3 over 3 is equal to 1y. And on the other side, when I multiply by 3 over 1, when I multiply across the top, I get 3. When I multiply across the bottom, I get 5. And that does not simplify. If you try it, 3 fraction 5 equals 3/5. It does not simplify. Applications. So we want to solve. It says here, yesterday a cow was milked. Today, the cow gave 4.4 gallons of milk, which is 0.9 gallons more than yesterday. Write an equation to model a scenario, and then how much milk was given yesterday. So in order to write the equation to model the scenario, I use something called a verbal model. Basically, my verbal model is an in-between step between the word problem that we're given and our final equation. I kind of make a word problem, but I'll actually write words in my equation and some math symbols. And I'll make it very easy to turn that then into an equation. So check this out. It says, yesterday a cow was milked. I don't know how much milk the cow gave yesterday. In fact, that's a question. How much milk was given yesterday? So yesterday's milk is unknown. But I know that today it gave 4.4 gallons of milk, which is 0.9 gallons more than yesterday. So today's milk is equal to yesterday's milk plus 0.9. Today the cow gave 4.4 gallons of milk, which is 0.9 more than yesterday. I don't know how much milk was given yesterday, so I'm going to put that as my variable. And check this out. This is my verbal model. It's kind of like my formula for my problem. I have a formula that makes sense in terms of the word problem. Today the cow gave 4.4 gallons of milk, which is 0.9 more than yesterday. So if I take yesterday's plus 0.9, then all I do is I plug in the numbers into my little formula. So today they gave this much, yesterday I don't know, there's that. And now I can solve this equation relatively easily. So this is my equation that I need. And then to solve, well, we solve like normal solving. Here's my variable. I need to get rid of this plus 0.9. So if I subtract 0.9 on both sides, these cancel. We get x equals 4.4 minus 0.9. If you're not sure, you got a calculator. 4.4 minus 0.9 equals 3.5. Okay? So according to our problem, the cow gave 3.5 gallons of milk yesterday. Now let's make sure this makes sense. Make sure it fits into the problem. So if they yesterday gave 3.5 gallons of milk, today the cow gave 4.4 gallons, which is 0.9 more than yesterday. So we take yesterday plus that, it should equal 4.4, and it does. So this answer makes sense. B. In a small garden, a farmer has 12 rows of corn. In the whole garden, there are 96 stalks of corn. Write an equation to model a scenario, and then how many stalks of corn are in each row. All right, so imagine here I've got here a field. Here's my field, or the garden, I should say. And the farmer has 12 rows of corn. So here's his rows of corn. He's got 12 of them going this way. The whole thing, all the little corn guys in here, there's a total of 96. So it wants us to write an equation to model a scenario. And this is how many stalks of corn are in each row. So how many are in each row? So if you've got your rows going like this, we don't know how many are in each row. This already is almost my verbal model. I'm going to take, and if I have 12 rows of corn on each row, or 12 stalks of corn in each row, and if you multiply that by how many stalks of corn are in the rows, right, there's 12 rows, times by how many corns are in each row, that would give you the total number of corn. This is kind of like the area of a rectangle. How much stuff is on the inside of the rectangle? If it's 12 this big and how many this big? You know the total is 96. So here's my equation I'm going to solve. So equation, check. How many? Well, solve it. So in order to solve here, my variable is being multiplied by 12, so I need to divide both sides by 12. That's going to give me, well, 12 divided by 12 is 1x, and I don't need to put the 1. 12 divided by 96 divided by 12, I believe is 8. 96 divided by 12 is, oopsie, 96 divided by 12 is 8. So this guy has 8 stalks of corn in each row. So if there's 12 rows, 8 in each row, that gives him a total of 96. You could probably also solve this using a better picture than what I did. So if you did, if you drew this out nice and pretty and you made 12, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could actually start and just start cutting this up to see how many stalks of corn he would need. So right now he'd have 12. And now he'd have 24. And now he'd have 36. And 48. And, I don't know, 48 plus 12 is 60. And then 72. And then 84. And now 96, which means he has 1, 2, 3, 4, 5, 6, 7, 8 in each row with 12 rows of corn, giving you a total of 96. So you've got your equation method. You've got a visual representation, a graph, a picture that also works. Example C, this is one for you to try. It says a board was cut into 4 pieces. Each piece is 7 inches long. Write an equation to model the scenario, and then the question says, how long was the original board? Go ahead and try the problem on your own. When you are ready to continue, hit play, and we will go through it together. Okay, so here's my picture. I've got my board. And I'm going to cut it into 4 pieces. Each piece is 7 inches long. 7, 7, 7, 7. How long was the original board? 28 inches. Now, we need an equation, right? So, here's my verbal model. I have a board, and when you're cutting something into equally sized pieces, that's division. If you had a bag of Skittles and you were going to share with your friends and every friend gets the same amount, you would need to divide it into equally sized pieces. Okay, so my board is being divided into 4 pieces. And it says the result is each piece is going to be 7 inches long. So when I cut this, each piece is going to be 7 inches long. This, well, that's my verbal model. I guess to get the equation, you just chop the word board into your variable. Okay, so now your board cut into 4 pieces is 7 inches long. B over 4 equals 7. If you would solve this, times by 4 on both sides, you would get B equals 28. The same answer we set up there. Just this was using our picture and our brains and problem solving. This was using an equation. Letter D. A factory produced many light bulbs yesterday. It doesn't say how many, it just says many. The factory then sold 3,457 light bulbs, and now they have 2,872 light bulbs. Write and solve an equation to find how many light bulbs the factory produced yesterday. Okay, so this is a problem for you to try on your own. So if you could go ahead, pause the video, try it on your own. When you are ready to continue, hit play, and we'll go through it together. Okay, so verbal model. So they made a bunch of light bulbs yesterday. It says then they sold a whole bunch. Now, if you're selling a whole bunch, are you getting more or are you getting less? You would have less, right? You sold some. They're making money, but they're selling. Their light bulbs would go down for each light bulb they sold. So they had some light bulbs made yesterday. Then they sold some, and now they have some left over. This is my verbal model. This kind of fits the scenario they're giving me. Now, if I plug my numbers in here, yesterday, I don't know, variable. They sold 3,457 light bulbs. And now they have this many light bulbs left, 2,872. Formula. Write a formula? Check. Solve the formula, or solve the equation. So if we solve this guy, my variable is being subtracted by 3,457. So in order to solve, I need to add 3,457, because that's the opposite of subtraction. So if I add 3,457 to both sides, I get x equals, and if I add that up, let's see, I get 9 to carry the 1, 12 plus 1 is 13, carry the 1, 6. 6,329, and just to make sure I wasn't a bonehead and screwed up adding, 2,872 plus 3,457. Good, I can add. So this would be how many light bulbs they made yesterday. That's what my x is. X is how many bulbs yesterday? They produced that many. Summary. And it should say 3.1 here. Summary says, now that you've learned about solving one-step equations, give just a little brief summary on what you've learned or what you remember, or if you say, I didn't learn anything in this lesson, I knew this stuff already. Fine. Give a hint to somebody else who doesn't know on a step or two on what you would tell them about how to solve a one-step equation. Okay? Go ahead and do that summary on your own. This has been lesson 3.1. Thank you for watching.